Okay, so we're going to go through even and odd functions. And what an even and odd function is when you take a function and you take the variable inside the function, which in this case we have f at x. We take x, so we change the x to a negative term. And when we equate it all, if it equals the original f at x, it's an even function. If we take f at, negative x, and it becomes the negative of the entire function, then it's odd. So that's what he was kind of trying to explain with this piece of paper here. Okay? So, what we mean by that, and essentially we're taking the original f at x. So this is our f at x. We now apply f at negative x. Well, all that means is we replace all the x's with negative x in this question. Okay? So now I replace my x and this x with negative x. Okay? So we got negative x squared plus 6 times negative x. Well, what's negative x squared?
Is x?
X squared in the end. Okay? If we square it, it's still going to be... Think of it like this. What's negative x times negative x? That's going to be positive x squared. Okay? That's what that's saying. What is 6 times negative x?
Negative 6x.
Negative 6x. So what we've just discovered here is this is not the original function, okay? But it's also not the same as, okay? And I'm going to show you what this means. What that means is, we'll do that one in red here. If we were to take negative f at x, okay? Well, we know our original f at x was x squared minus that. Well, all that is taking a negative to the entire outside of the function. Okay? In other words, in this one, we distribute the negative term to both. So to be the inverse of this, what's negative times x squared? Well, that's negative x squared. And negative times positive 6x is negative 6x. So this would be the equivalent of that there. Okay? And if we ended up with this function here, this would be the equivalent of even. But if you notice, this is positive and this is negative. That's neither what we started with, nor is it a complete negative of the function. Okay, because the complete negative, both of the terms had to be negative. So in this case, this is neither even nor odd. Okay? Does that somewhat make sense, that one?
Yeah.
Okay, so we have neither here. Is that an E or I first? And E-I-T-H-E-R. Spelling neither. Okay. The next function they gave you was f at x was equal to what?
Negative x cubed plus x.
Negative x cubed plus x. Okay. Same idea, we take f at negative x. This is how we test it. Well, we're replacing, remember, we're just replacing that negative x here. Okay? And in this one, this is, which one is this? C? Mm-hmm. Okay. C in this function. We're going to take that and replace it. So we get negative x cubed plus negative x. Okay? Well, when we do that, what's negative x cubed?
Negative x cubed.
Yeah, that's right. So then we have negative times negative x cubed. Think of it like that. Does this make sense where I just kind of incorporated the bracket?
All right.
The reason I'm doing that is because I still have the negative on the outside. I haven't included that yet. Okay? And then what's positive times negative x?
Negative x.
Negative x. And then what's negative times negative x cubed?
Is it x cubed?
Yeah, positive x cubed minus x. Okay. Well, it's definitely not what we started with.
Yeah.
Let's check if it's the inverse of the, or not the inverse, sorry, but the negative of the entire function. Well, to be the negative of the entire function, essentially distribute a negative to the original function. Okay? Mm-hmm. Again, we're going to distribute it. Well, what's a negative times a negative?
Positive.
Positive x cubed. And positive times a negative?
Negative.
So
that makes sense.
Are those equal?
Yes.
So that is an odd function. Okay? So that makes that an odd function. The next function they gave you, absolute value. So the negative of absolute value
2x minus 5.
That's 5. Okay, absolute value. Same idea. We're going to replace the x with a negative. Well, absolute value of this function is already being multiplied by a negative term. Okay? So, whatever our answer is going to be, remember absolute value is going to give us a positive answer, and then we're going to multiply it by a negative. But let's work this out first. This become 2 negative x minus 5 absolute value. This becomes negative. Negative x times 2 is going to give us negative 2x minus 5. Not rounded. Let's be square. Okay? Now, technically, this answer is going to be a negative answer in the end. But let's look at the function. Is this function the same as what we started with?
No.
No, this function is not the same as what we started with, okay? So it's not the same as f at x. So we know that f at negative x does not equal technically f at x. The function's different, the way it's written. The actual value of it, because the absolute value is going to be the same. Let's also test this. If this was a negative f at x, well, that would be like taking this. Negative, again, think of it like we're multiplying negative 1 times negative absolute value. I know this looks like subtraction here. I'm trying to think of a way. Again, imagine that's a negative 1. If we have a negative here, that could be like a negative 1 times the function, okay? So we're multiplying the outside of this function 2x minus 5. These are absolute values, okay? But what's that negative 1 times negative 1 really going to give us? A positive. So think of it like positive absolute value 2x minus 5 as the inverse of this. Well, is that what we got here? Are those functions technically the same? They're not written the same. Just like that's not the same as the original function. So in this case, because it's not the same as before or same as the odd version, it's neither again. Okay? The value we might get the same, but the actual way it's written, because we end up with another negative inside the absolute, it's not the same thing. Okay? This one's a tough one though. Think about.
Yeah.
And then let's think about the last one. What's the last one there?
It's f at x equals absolute value of negative 3x y plus 2. Plus 2.
Plus 2. Okay. Same idea. The negative of x, well, absolute value negative 3 times negative x plus 2. Okay. In this one, we're going to get absolute value of 3x plus 2. And this one is not the same as what we started with.
But isn't it kind of the same?
It's not the same as what we started with. Ah, okay. Not the same as what we started with, so... But the value is going to be the same.
Yeah.
That makes sense. Because the value is going to be the same, oh, sorry. This is what our answer was. The reason this isn't the same is say we plug in the number 1 here and we plug it in here. Okay?
Okay.
2 times 1 gives us 2.
Yeah.
Minus 5 gives us what?
Gives you negative.
Negative 3. What about negative 2 and what do we say this was? 1?
Yeah.
If I plug 1 into this, what's negative 2 times 1?
Negative 2.
Minus 5? Negative 7. And this one we would have got negative 3. Very different answers. Hence why it's not the same. Okay? But because this is multiplied by and with an absolute value, if I plug 1 into here or 1 into here, in this case I get negative 3, in this case I get 3. But because it's absolute value, the amount I get is still going to be 3 in the end. And there's no change to this. Okay? So essentially what they're asking you is how does that change the value of the function? So in this case, here the value of the function changed enormously. We went from when x is 1 being negative 3 to negative 7. But here we went from having the exact same answer. It was 3 no matter what. So in this one we actually end up with an even number because the value is the same. So in this one we get an even number because the value of what we get when we plug it in is still going to be the same as what we had started with, even though the function's written a